What is going on, guys? Welcome back. In this video today, I want to clarify some confusion when it comes to certain buzzwords like AI, machine learning, data science, LLM. What do they actually mean? What is AI? What is not AI? What is machine learning? What is not machine learning? A lot of people seem to confuse these, so let us get right into it. Alright, so we're going to talk about buzzwords in this video today, and my goal for this video is to give you a terminology 101 so you can use the words correctly, because a lot of people seem to be throwing buzzwords like AI, machine learning, Gen AI, ASI, AGI, deep learning around, and they don't know what they mean. They conflate the terms, they confuse the terms with one another, they use the incorrect terms when they're talking about stuff, and I want to just give you an overview so that you can use the terms correctly and so that you can correct people, especially business people, when they use terms that they shouldn't be using because they're referring to something else. So I want to give you just a casual overview here, and for this I'm going to use my favorite visualization software, MyPaint, and we're going to get started here with the most commonly used term, which is AI, artificial intelligence. Now, what is AI? What is artificial intelligence? What counts as AI? What does not count as AI? I want to say right away, people might define these terms differently, especially with a term like AI. There is a lot of wiggle room. People can use it to call or can use it to refer to different things. But at least to the commonly, or at least the commonly accepted definition, the one you find on Wikipedia also, is that it's a pretty broad umbrella term for anything where a machine shows intelligent behavior. So machine intelligence is actually overall AI. So if I have a computer that performs intelligent actions using search and optimization, that can be considered AI. If I have a knowledge-based system, an expert system that makes decisions based on the knowledge base, based on the database, that can be considered AI. If I have let's say logical stuff. So I have like inference from logical rules, and I use some algorithm that or some logical rules, inference rules, to come to a certain conclusion, to prove something, to come to a decision. That can also actually be considered AI. Now, what also is part of AI is something called machine learning. And this is a term that you definitely know about if you're watching this channel. Machine learning is part of AI, but machine learning is not equivalent to AI. We're going to talk about machine learning here in a second, but maybe let me pull up here the Wikipedia page. What we have here is artificial intelligence. In its broadest sense, is intelligence exhibited by machines, particularly computer systems. Now, it says here in its broadest sense, but if you scroll down, you're going to see that quite a lot of stuff is actually counted as AI. So we have, these are the goals here. Here you go. Technique, search and optimization, local search, logic, formal logic, probabilistic methods, classifiers and statistical learning methods. This is now actually more machine learning, artificial neural networks, also machine learning / deep learning. Actually here we already have a spoiler for what we're going to talk about in this video today. But you basically have many different things that can be counted as AI if you define AI in the broadest term, which is that it's just, in general, when machines exhibit intelligent behavior, as it's put it here, intelligence exhibited by machines, particularly computer systems. So actually, you shouldn't really attack people when they talk about AI when a computer does something in an intelligent way. Because they might actually be right in the broadest sense. Anything that, even if it's just an algorithm that you hard code, if there is some optimization, some intelligence going on, you can actually legitimately refer to it using AI, or refer to it with the word AI. I know that a lot of people will be triggered by this because AI usually is associated with machine learning, but it's not necessarily machine learning. AI is an umbrella term for all these things, and machine learning is a specific part of AI, which we're going to get to now. Machine learning is a specific way of exhibiting intelligence. So a specific type of algorithm, a specific type of approach where the computer system that is going to show intelligent behavior is doing that by learning from data. So the idea is I have something here, let's use yellow color. I have something here which is my model, whatever it looks like. It can be very different. And then I have something else, which is data in whatever form that is. This could be CSV files, databases. This can be sequential data. This can be visual data. It could be images. It could be text. It could be stock prices. It could be anything. And the idea is that the model looks at the data. So the data goes into the model. The model then trains, so it becomes more intelligent. And in the end, now it has a certain level of intelligence. And the idea is if I get some new data that I have not seen before, so let's call this here new data, the idea is that the model can then handle this data quite well. So to give you a practical example, if I have a model, this could be now, classic example is you have images of cats and dogs. So you have cats and dogs. And the idea is I have a bunch of images here that my model can look at. My model, of course, has no clue what a cat is and what a dog is, but it can look at all these images. And for every image that I feed into my model, I also tell it this is a cat. This is also a cat. This here, however, is a dog. This here is also a dog. This here is a cat again. And this here is now a dog again. And by showing it enough images, what happens is at some point it's intelligent enough. And then I have this new data where I have images of cats and dogs, but I don't have the labels. I have a big question mark. And my model can now do the job of taking the image and tell me, oh, this is a cat. This is a dog. My model can now do that because it learned from the data. So that is machine learning. Machine learning means we're learning from the data. It's a subfield of AI, and we're not explicitly programming a solution. So we don't have something like if I have an image here of a cat, whatever. I don't go to my model. Oh, this is not a beautiful cat. I don't go to my model telling it, okay, go pixel by pixel or use some filter and look for pointy ears and look for whiskers or something like this. What I'm doing is I'm just showing it examples and the model learns these things by itself. So I don't have to really explicitly program anything in. What I do have to program is the learning algorithms. So I can learn, or the model can learn things in different ways, depending on what kind of model it is. It can be a neural network. It can be a K nearest neighbors, so K and N. It can be a support vector machine. It can be a neural network. It can be a simple neural network, like a sequential feed-forward, fully connected neural network, or it can be a convolutional neural network. It can be a random forest classifier. It can be a decision tree classifier. There are many different ways that you can do machine learning in, but the pattern is the same. I have data, I feed the data into the model, I apply the training logic, whatever that is. I have a bunch of videos on this channel going through how to implement stuff from scratch, how the individual algorithms work. But the idea is you learn stuff in a certain way, but you don't explicitly program in the solution, you just program in how you learn stuff. So whenever you do that, it's called machine learning, and machine learning is a subfield of AI. Now, we already talked about neural networks and convolutional neural networks. This brings us to another term, which is deep learning. Deep learning is now a subfield of machine learning, which is we use deep neural networks. So we still have the same structure. I still have a model, and I still have data. Nothing has changed. This is still machine learning. But the model now is not any model. It's not random forest. It's not support vector machine. It's not decision tree. It's not K nearest neighbors. It's not anything like that. It's either a simple neural network. It's a convolutional neural network. It's a recurrent neural network. It's a transformer-based architecture. Or anything else that you can think of here. It's a GAN, it's a autoencoder, whatever you're trying to do, but you're working with neural networks. Now, neural networks are these things where you have some inputs, and these inputs go into neurons, and then these neurons go into other neurons, and they're all connected in the case of a fully connected layer. Actually, I have this connection already. And then they have weights and biases. I'm not going to explain how neural networks work now, but that would be a normal neural network. In the case of a convolutional neural network, you have these kernels of certain size, and then you have pooling layers and all that. In the case of recurrent neural networks, you have also some hidden state that's fed into the into the next iteration or the next time step. So you're basically feeding into yourself some information. You could also represent it like this. You have a connection to yourself, basically. So whatever it is in detail, it's just neural networks. It's neural networks of different kinds with different activation functions and different nuances. But deep learning is machine learning. So again, just to make the connection, AI is an umbrella term. Part of it is machine learning. So a part of AI is machine learning, and a part of machine learning is deep learning. Deep learning is just a subfield of ML. ML is a subfield of AI. And deep learning focuses on working with neural networks. If you don't know what neural networks are, I have a video explaining that quite quickly. You can look at that if you want to. But basically, it's a certain type of architecture on how, or many different types of architectures, a certain type of machine learning model, a category of machine learning model, a family of machine learning models, we could say, that learns in a specific way. Now, then we also have something called Gen AI or generative AI. Now, I wouldn't actually draw the connection here that it's a subfield of deep learning. I would maybe do a wavy arrow here to say not really a subfield of deep learning, but nowadays what we're talking about is mostly a subfield of deep learning. So we have Gen AI, or as I said, generative AI. And this means AI that produces images, AI that produces music, AI that generates text, and so on. And of course, what we have here is we have LLMs. This is stuff like GPT, stuff like Claude, stuff like Gemini, stuff like Mistral, stuff like Llama, right? But also, of course, stuff like Stable Diffusion, stuff like Midjourney, stuff like Dolly, and Flux, and all these different models that you have out there. And there are also other models. You also have Lava and whatnot. But basically, generative AI now is a subfield partly of deep learning. I'm gonna explain in a second why that is the case. But basically, it's a subfield because we have all these modern things that we know about ChatGPT, Midjourney, Stable Diffusion, all these different language models, all these different visual models, all these different models that produce something. But even older things like GANs, for example, are also generative AI. They are not necessarily transformer based, but they're generative AI. But then you also, of course, could have anything that just generates art, that generates music, and it doesn't have to be even machine learning. So if you have some AI that is not based on machine learning, that has some algorithms, some optimization, some other approach to get to a piece of art that's generated by a computer, you could theoretically also consider it generative AI. But practically speaking, nowadays, when we're talking about Gen AI, we're talking about these large language models and these diffusion models and all that. And most of them, not all of them, are transformer based. So they're based on this beautiful architecture, the transformer. If you don't know what a transformer is, I'm gonna refer you here to a paper. So let me just open up the respective page. It's called Attention is All You Need. If you've never heard about this, I would recommend you check this out. It's a paper released in 2017. It's one of the most important papers out there, and it explains what a transformer is. It introduces the transformer architecture, which is the basis of all the large language models that we know nowadays, and of many other models as well. So I would really recommend to you that you either read the paper itself or you watch a video on the paper. There are YouTubers out there that have good videos on it. Maybe I'm going to do one myself someday, but that is this key architecture that most of the Gen AI field is based on. So again, to summarize this, AI umbrella term, ML, machine learning, is part of AI, a subfield of AI where we learn using data and we don't specify the solution to a problem like recognizing cats and dogs. We just specify on a meta level how the model learns, and then the model learns the patterns itself. Then we have deep learning, which is machine learning using neural networks. And then we have Gen AI, which theoretically doesn't have to be deep learning. Most of the time it is, and most of the time it's also transformer based. All these new AI things that we hear about that are the cause, unfortunately, for many buzzwords being used are generative AI and are transformer-based models. So that is the most vibrant, on the rise field, I would say, right now. So then we also have another term I want to talk about, which I'm going to put a little bit away from all this, and this is data science. What is data science? What does it mean to be a data scientist? How does it differ from machine learning? How does it differ from artificial intelligence? What is data science? And for this, again, I want to pull up the Wikipedia page, the corresponding Wikipedia page, which tells us that data science is an interdisciplinary academic field that uses a bunch of things. The important thing here is to extrapolate knowledge and insights from potentially noisy, structured or unstructured data. So data science is just a huge field, an interdisciplinary field, which means it doesn't focus just on computer science, it doesn't just focus on math, it doesn't just focus on machine learning or on visualization or anything like that. It means having a lot of data, extrapolating knowledge from it, getting knowledge and insights out of the data. This can be with the use of machine learning. So data science can actually, let's use do we have a color that we have not used yet? Yeah, this one. So data science can actually, okay, this is not a good arrow. Data science can actually make use of machine learning and also AI and Gen AI and deep learning actually, so it doesn't really matter. Can make use of all this stuff, but it requires also, in addition to that, domain-specific knowledge. So for example, if we're working with medical data, you need to have also medical knowledge. If we're working with financial data, you should also have financial expertise. If we're working with something else, you should, know something else. And you need to have domain-specific knowledge, you need to have business understanding, you need to have math, statistics skills, and usually nowadays it also involves a lot of coding and usually also machine learning. So data science is just an interdisciplinary field. Maybe let's put this down here, interdisciplinary field, and the goal is to extrapolate knowledge out of data. So whenever you have huge amounts of data, or actually when you have huge amounts of data, we could also call this big data. So this might be another term, but let's say we have some data here, and we want to take this data and get some insights. So I'm gonna just represent insights now as some bars here, right? Like this, whatever. You want to get some insights out of the data. How you do that doesn't have to be ML. Sometimes can just be statistics, but you want to get some insights from the data. Now, maybe as I said here, we could say that if the data is very large, if we have huge amounts of data, so if we have huge amounts of data, we could call this big data. So working with a lot of data, processing it on multiple clusters, this could be called big data, or this is called big data. But data science in general, the full process of getting insights, which includes also domain-specific knowledge. So finally, I want to talk about two terms which are really used frequently as buzzwords, and they are related to AI, so I'm going to put them here next to AI. And these are the two terms, AGI and ASI. So AGI means artificial general intelligence. Now, some people claim that the models that we now have, the LLM models, are already AGI because they can already do stuff that humans can do, and they are already more intelligent than humans in a lot of tasks. It depends on how you define it. It's a debated term. I would personally say that's not the case. I wouldn't call what we have right now AGI, but the definition for AGI is actually that it's good, that it's as good or better than humans in a wide variety or a wide range of tasks. So maybe here, let me pull up also the Wikipedia page, and we can take a look at it here. So basically, artificial general intelligence is a type of AI that matches or surpasses human cognitive capabilities across a wide range of cognitive tasks. So it's not an AI that is super good at chess. It's not an AI that's very good at math. It's good at most things, as good as humans or even better than humans. That's the idea of an AI. Now, some people claim that ChatGPT already does that because it's more intelligent than, or as intelligent when it comes to coding, math, and general knowledge and geography and all that. You know, if you think that ChatGPT is an AGI, you can think that. I personally don't think it is already something that should be considered an AGI. It's definitely closer to AGI than what we had a couple of years ago, but I would still not hype it as AGI. And then we also have, this is also listed here, ASI, artificial superintelligence. And artificial superintelligence basically means it greatly exceeds human cognitive abilities. So it's far better than what humans can do, and it's not even comparable. And this is oftentimes also related to the idea of an intelligence explosion. And actually, I have right now, not for the video, but in general, I have a book here on my site, which is called Superintelligence from Nick Bostrom. It's a classic. It's already, I don't know when it was published. It's not a new book. It actually was published, I think, 2014. I think so. And this is a book about superintelligence, about artificial superintelligence and how it could happen, what the dangers are, what the risks are. So that's definitely something that's interesting as someone who's interested in the philosophical and in the futurology of all it. But these terms are thrown around nowadays as buzzwords all the time. Everything's AGI, everything's ASI. People hype it up, and I don't think that this is necessary right now. We do have very powerful Gen AI models. We do have very powerful deep learning models, but we don't need to necessarily call everything that's a little bit better than before, or even a lot better than before, AGI or ASI. So I hope that this was a good overview. To summarize again, AI umbrella term, machine learning part of AI, deep learning part of ML, Gen AI mostly part of deep learning, data science interdisciplinary field that tries to get insights from data. When we work with huge amounts of data, this is called big data. And then we have AGI and ASI, AGI being as good or better than humans, ASI being massively better than humans at basically everything. And it could lead to an intelligence explosion that might be uncontrollable. So that's it for today's video. I hope you enjoyed it and I hope you learned something. If so, let me know by hitting the like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video and bye.